Hey folks, we're going to solve a classic interview problem. It's really good practice for working with matrices, which can get, well, it's just a very common, I suppose, data structure that you have to work with in an interview setting. So here we're given a matrix consisting of these numbers 1, 2, 3, and so on. So the way the matrix is given to us is it's a list of lists. Seen right here. So the first row, 1, 2, 3, is the first list of this list of lists. The second row, 4, 5, 6, is the second list in this list of lists. And what we are to do is actually to return an array consisting of the elements of this matrix in what they call spiral order. So starting from the upper left corner, go right until you hit a corner, then go down until you hit another corner, and keep going in spiral form. So already we know we're going to sort of visit each cell of the matrix. So let's write code to visit each cell of the matrix. But first let's start with defining a constant here. So for these problems, you usually need the number of rows, which is this right here, the number of lists. And you're also going to need the number of columns, which is the length of the first list. You can do it that way if you want. And we actually don't have to worry about malformed matrices because in the matrix we're given, we're guaranteed via this constraint that there is at least one element in it. So we won't be given like an empty matrix or something. So we are going to iterate through each cell of the matrix, which suggests sort of something like this. So we're going to loop r times c times, which is the size of the matrix. So the initial coordinate is going to be 0, 0. So let's, create an initial coordinate here. And we know we're going to return an array, so let's allocate the array. Initially is empty. And remember, we're going to put the elements of the matrix into this array, then return it. The first thing we're going to do when we're visiting a coordinate, and the first coordinate we're visiting is 0, 0, we're going to add the number at 0, 0, which is 1, to the result. So it's going to be like this. So now we have a, now what do we do next? Well, we have to go right. And we can sort of look forward and see that when we're facing right and and there's more to go, we're going to go right. But once we hit this corner, we're going to actually go down. So this indicates that we need to keep track of the direction we're in. So let's keep track of the direction we're in, and initially we're facing right. So the directions are in this convention of using constants, harks back to my days of writing parsers and so on. So one direction is right, another is down. I'll make that 1. Left will be 2. Up will be 3. And I'm sort of writing this code in a somewhat verbose way because it's sort of easier to understand and also pretty straightforward to code up. So the direction we're initially facing is going to be right. And we're going to, the way in which we move to the next cell will differ based on the direction we're in. So let's just create like, let's just handle each case separately. So D, if we're facing right, then we're going to do something. we're facing left or down, we're going to do something else. If we're facing left, then we're going to do something else. And if we're facing up, then we're going to do something else. So we're at 0, 0. We want to go right. Going right means adding 1 to the column, like this. So that works until you hit the end. So we have to make sure before we add 1 to the column that doing so would not take us out of bounds. So if c plus 1 is, it's not out of bounds, and go ahead and do this. Otherwise, we're going to change directions. We're going to start going down, so we're going to change the direction to down. And going down means adding 1 to the row. So if we're in row 0, we're going to go to row 1, like that. So let's go ahead and fill this out for all the different scenarios. So if we're going down and we keep going until doing so would take us out of bounds. So to go down, that's adding 1 to the row. We only do that if doing so would not take us out of bounds, like that. Otherwise, we're going to change direction to left. And to go left means subtracting 1 from the column. So if we were in column 2, we're going to go to column 1. So see that. If we were going left, we're going to stop going left. If doing so would cause us to go off the grid. So, well, to go left is just you do this, but you subtract 1 from the column, but you only do so if doing so would not take us off the grid. So you have to check first, like that. And for up, oh yes, and if we would go out of bounds, then we would change the direction to up. And going up means subtracting 1 from the row. If we were in row 2, we're going to go to row 1. So like that. For the final direction, if we're going up and we so we're not going to go out of bounds in this case, really, because when we go up, we're going to go 1 until we hit this cell right here, until we hit 1. So we're going to do something else. We need to know when we have seen a cell before so that we can look ahead and see if we're about to move into a cell we've seen before, because that indicates that we should change directions in a spiral order again. So in addition to adding the cell we're in to the result, let's go ahead and sort of null it out. So this is one way to keep track of when we have seen something, by just marking it in some way, in this case just as none. So basically go up, which is subtracting 1, if doing so would not bring us out of bounds if r minus 1 is greater than or equal to 0. And we actually, can the numbers be 0? I just realized an issue. Yes, the numbers can be 0. Okay. So let me mark. Anyway, so go up if doing so would not bring us out of bounds. We won't really be using this. And basically, going up is not has not been nulled out, so it's not none like that. Otherwise, let's say we're at 4, and by going up, we would encounter none, because we've already seen 1, so we've set it to none. We want to turn right. So D is right, and right means adding 1 to the column. So we actually, what we've discovered here is that we want to change directions when going forward in the same direction we're in would lead to something we've seen before, to a cell we've already visited. So let's just go ahead and just modify all the different cases to also, all the different tests to include that. Matrix on, and also here. So that should be it. We've handled all the different cases. Let me show code so you can see it all at once. It's kind of a lot of code. This is a very verbose implementation. So let's, I think I got it right. Let me just run the code. That case is correct. Let's run on this one right here. Like that. And so on. Let's submit. And that works. So let me display the full code. If I could just, well, the pertinent part is like this loop right here, so I'll just display that. And enjoy. And that's how you work with matrices and solve this classic interview problem.